In VCE General Maths, finance and recursion is the second biggest topic, and making mistakes in the SACs or the exam could shatter and break your study score. For those new to the channel, my name is Marshall and I scored a 50 for General Maths. In this video, I'll be discussing errors that I made in finance and recursion during practice exams so that you can avoid these mistakes immediately. So mistake number one is forgetting to divide the interest rate by n when it compounds n times per annum. So for example, here in the question, it tells us the interest rate is 6.4% per annum compounding quarterly. If we're answering a question that says how much interest will be charged after one quarter, we first have to divide the number of periods per annum. So here it is quarterly, so we're going to do 6.4 divided by 4. Then we'll divide that, which is 1.6, by 100, so equals 0.016. Then we can multiply that by 30,000 and we get $480. If the question said it was 6.4% per annum compounding monthly, then we would have to divide that by 12 before making calculations and so on. However, if we're using the CAS finance solver or the financial compound interest feature, we put the interest rate per annum into the calculator, do not divide. So here we can just put 6.4% straight in the CAS finance solver when using it for calculations. So mistake number two is when you put your values into your finance solver or your financial compound interest feature on your CAS calculator, make sure your values are positive or negative. So double check those inputs. So depending on what type of financial circumstance that the question is introducing, whether it be depreciation, loans, annuities, perpetuities, etc., it'll affect whether you have to use positive or negative values in your CAS calculator. So here's a table which should be on the screen. It summarizes when things should be positive or negative, and you should definitely put this in your bound reference book. Accidentally using a positive when it's meant to be negative or vice versa will end up leading you to the wrong answer, so make sure you always double check according to the question. So to avoid mistake number three, you have to make sure that all of your values are in the correct format. So this is an easy thing to do, but it's also a very easy thing to forget. So when you're writing recurrence relations and things, make sure n plus 1 or n in the vn and the vn plus 1 is in subscript and it's not like the same size. And also always include the dollar sign in your final answer, round to the nearest dollar, round to the nearest cent, depending on what the question is asking you. These are all very easy things to do, but they're also very easy things to forget, and they can make you lose marks. Not good. So mistake number four that you could fall into the trap of is getting confused between a recurrence relation and the nth rule for a given model. So a recurrence relation shows the relation between a certain value from one period to another period. And in a recurrence relation, we'll have terms such as Vn plus 1, Vn, and V0. So of course, it doesn't have to be the letter V. So here in this example, it's G, and we have G0 equals 15,000. And then Gn plus 1 equals Gn minus 1,314. So as we can see in this recurrence relation, it shows that we started with 15,000 and then every time we subtract 1,314 from it after each period. So the nth rule of a given model, however, is something else. It goes straight to a term, and it's a good shortcut tool that works on some finances. So it'll only have like the Vn term and then have the n somewhere else. So using the previous example, we can make it into this shortcut formula. And as you can see, it's Gn equals 15,000 minus 1,314 n. So using this model, we can substitute n for the number of periods and calculate it instantly rather than just going from period to period using the recurrence relation. So to avoid mistake number five, when you're given a finance graph, check for linearity or curvature. So in this graph over here, we can see it's going downwards. But if we use a ruler and place it and put it through the points, we can see that there's actually a curve going downwards. So since it's a curve going downwards and it's not a straight line, we know that this isn't flat rate, but a reducing balance depreciation. So we're going to mark the answer as A. And also sometimes as well, you need to check the axes. On the y-axis, it could be interest charged per period, but here we know it's total balance. But if it is though, it will change how the graph will look. So make sure you check your axes so you don't avoid small mistakes like that if they try to trip you up. Mistake number 6 is calculating the final repayments incorrectly. So this one's a bit more detailed, and I'll do an example question right now. Looking at the contextualization of the question, we see that someone's borrowed $30,000 and he's taken a loan for it. And we see that it's charged at 6.4% per annum, compounding quarterly, and he finishes paying the loan in 6 years. So just from that, we know that it's going to be 6 times 4, 24 payments in total. And then there's a recurrence relation, and we can see that through the recurrence relation, there is a payment, quarterly payment of $15.18 per quarter. And then seeing the question itself, it says the final repayment will differ slightly from the earlier payments and determine the value of this final repayment. So this is the type of question I would be using the finance solver for. So we know that n is 6 times 4 because it's 6 years and quarterly payments, which equals 24. And we know that the interest rate is 6.4%, and we can just put that straight into the calculator without making any divisions. And then our present value is going to be positive 30,000 since he's taking it out from the bank. And our payment will be negative 1515.18 since he's paying it back to the bank each time. And future value, we're calculating what that is. And payments per year and compounds per year is going to be 4 because it's quarterly. Then we find out what the future value is, so that is 0.138. So this means that he's actually overpaid by around 13.8 cents. So we can just copy this value just to make sure. And then we type in 1515.18, and then we subtract that overpayment, and we see that it's $1,515 and about 4 cents that his new payment will be. So to avoid mistake number 7, check to see if interest is calculated on the minimum balance in an amortization table. So I'm not entirely sure if they do this anymore, but there can be questions where they give you an amortization table like so for an investment, and the catch is that the question asks that interest is calculated and paid on the minimum balance rather than whatever it is at the end. So making sure that you read the question carefully for any keywords like that, and then you won't be able to make mistakes. If you guys found this video helpful, please subscribe with notifications on. So if you're studying, you're obviously not going to see YouTube videos, but having notifications on will help you remind you that I'm making a new video. If this reaches 80 likes, I will publish one about matrices, mistakes to avoid in matrices as well. So thank you guys for watching, and see you later.